All right, what we're going to look at is the 8 parent functions. Again, we want to graph with at least like 2 or 3 standard points. So just kind of coming up with them really quick, we have f of x equals maybe 2. That's our constant function. You can put any number there really, but that's saying we're constantly 2. So our outputs are all 2's. Let's just come up with another one. We have f of x equals x. This would be our identity function. And that one's at 0, 0, 1, 1, negative 1, 1. So we have that nice diagonal line. Kind of going up in order here, x squared. That would be our quadratic, or you can call it the squaring function. That's at 0, 0, 1 gets you 1, negative 1 gets you 1. And it's that kind of U shape. And then we have the cubic, x to the 3rd power. And as long as you have all of these, you're good. They don't have to be in the same order as mine. And then we have the roots. So we'll talk about the square root. And that one's at 0, 0, 1, 1. You could put 4, 2 if you want, but that puts us kind of off the chart, but we know that's where we're headed. No negatives on that. And then we have the cube root of x. That one has 0, 0, 1, 1. This time you can plug in negatives because it's an odd root, but it's not going to grow as fast as the cube function. This is the cube root. If you want to try and remember them, one thing I kind of picture, if you look at the actual expression here, it kind of goes sideways compared to if you look back at x cubed, it kind of goes more up. So might help with that vertical or sideways kind of look to it. But also just knowing what the cube root does and what the cubic does. The cubic will grow really fast as different from the cube root. All right, we have also, let's see, the absolute value of x. And that's the nice V, 0, 0, 1, 1, negative 1, 1. And then it does actually grow nice and straight, like our diagonal line, but all the negatives become positive. And the last one is the reciprocal function. And that one's a kind of weird one because we have vertical asymptote because we can never be 0 in our denominator. And also the fraction will never equal 0. So we have these things called asymptotes, which we'll explore a little bit more in a few weeks. 1 gets you 1, negative 1 gets you 1. And we have these kind of branches going on. Okay, so those are the 8 functions that you should know. Now let's transform them. So first listing the transformations, then we're going to graph the parent function as a dotted graph, then use kind of those standard points that we just plotted to make our new function. So first, negative will be a reflection. It's outside our function, so it's across the x-axis. We have the negative 2, that's moving us to the left 2 spaces horizontally, and then the plus 1 is moving us up 1. The parent function is x squared, so we're going to plot that dotted line. That's what it said. So there is our parent function. And so we're going to take all of those points, move them left 2, up 1, and it's reflected. If we're kind of following like order of operations, we could think about, okay, let's move it left 2, and then we're going to flip it downward. So our points are kind of going downward now. But then it also says move up 1. So moving those points up 1 space would actually put us right there. Just don't do the reflection at the very end. It can only be done within this horizontal part. Like you don't want to move it up 1 and then reflect it. Because what I see some people kind of end up doing is they would have the vertex in the wrong spot. Again, you can verify that you're right. Let's just check a point. So it looks like our vertex there should be negative 2, 1. So if we plug it into the original function, we should end up with something true. So that inside could become 0. So we're just going to get 1. So f of negative 2 equals 1. It checks. And you can check 2 other points if you want to as well. All right, for number 3, we have a reflection again, but then there's a negative inside. So we have 2 reflections. So we reflect over the x-axis. We reflect over the y-axis. And again, this is because x-axis, because our outputs are going to change sign. This reflects over the y-axis because our x's are going to change sign. And then lastly, we're going to move down 3 because that negative is outside of our function. So if we want to sketch that graph, well, the parent function first, 0, 0, 1, 1. Okay, so reflecting over the x-axis, that's going to be kind of moving down. I'm going to kind of do baby steps here. It's going to be kind of doing this thing, and actually the last one I should have done dotted, so let me fix that. So I know that's my parent function, and let's use a different color to show. Okay, so we're reflecting it, so it's doing something like that, but then it's going to reflect over the y-axis, which puts us now here, going that way, and then it says move down 3. So our final answer for this, down 3, would be here. And there's our other main point. If you're like, wait a minute, that was a lot of flipping around. Well, let's check. I want to check this point right here. So I'm going to check -1, -4. So it says f of -1 equals negative square root of -1, and then -3. So this will become a +1. The square root of 1 is 1. So we're going to have -1 minus 3, which is -4. So it fits. So again, if you're not sure about that reflecting process, just make sure that you check your points. So now inside here, this one is a little bit less kind of clear. We know that we're doing a reflection again. So reflect over the x-axis. Now inside there's a few different ways that you can do this. I think the easiest is to factor the 1/2 out. So we can see 1/2 times some quantity. But I mean, if you don't like that, there's other things that you could think of. This is still going to take half of every x value you plug into it. So our x's horizontally have to double. So it's a horizontal, let's write it down here, horizontal stretch by 2. And then it looks like we're going to move to the right 3. But because we're being stretched out, we got to think about that actually kind of tripling. So that's where it comes in kind of nice. And I'm just going to rewrite it here. If I take the 1/2 out, it's going to be 1/2 x minus 6. So you can see it kind of doubles up that 3 there. So we're really going to move right 6. Another reason to think about, well, how does that happen? Because if I think about, again, what makes that go to 0, that's been a little bit of a trick. Like, when is this equal to 0? Well, to solve that, we'd say 1/2 x equals, move the 3 over. We get 3, and then multiply by 2 to clear out that fraction, x equals 6. So we know we're going to have to be on that 6. So if you kind of start with that, trying to see what makes your function go to 0, that's sometimes helpful too to get that shifting part correct. So let's deal with coming from our parent function, draw that dotted. So it wants us to reflect over the axis. So I'm going to do this in a few steps so we can see that happen. So we're going to reflect over the x-axis. Okay, and then it says it's a horizontal stretch by 2. So all of our inputs, before we'd plug a 1 in and get 1, now we're going to plug a 2 in order to get that same 1. Do a different color. And same thing, a -2. So the graph that we're talking about is going to be this guy. So again, in blue, we have negative, absolute value of x. In red, we're taking that same negative, and we're just having to double up our x's. Because again, the function's taking half of all of those. And then when we transfer over 6 spaces, we're going to be here, and again, it's going to go out 2 spaces now. And so the blue one is our actual function. This is -1/2 of x minus 3 right there. That's our green guy. And you can check if you want to, that's fine. Either way would work for you. All right, for 5, 6, and 7, they give us a function. They don't tell us the equation for it, so we're not going to be able to kind of totally sub in there. Let's look at the transformations. Again, we have that reflection over the x-axis. the -1 is inside whatever this function is, so that's going to move us to the right 1, and the +4 will move us up 4. So for these, I like to like grab on to the different pieces. So what I mean is the first thing I want to think about is the reflect part. So I grab onto a few main points so I can make that shape. And so -3, 3 would become -3, -3. +3, 3 would be 3, -3. And 5, 3 would be 5, -3. Oops, I'm going to make that open circle because that's what it was. So this was just finding the negative of that. So this is negative our f of x. But then we said we're going to be moving it to the right 1 and up 4. So taking each of those points, right 1 up 1, 2, 3, 4. So that's kind of the top of that circle thing. Again, let's move right 1 up 1, 2, 3, 4. Right 1 up 1, 2, 3, 4. So you kind of have that little upside down cup. And then this guy, right 1 up 1, 2, 3, 4. And that's an open circle. So the actual graph would be this guy. Again, it's a little kind of circular thing as best you can. There's the sketch. That blue graph is the sketch. That is equal to negative f of x minus 1 plus 4. And you can still check here, so if you wanted to check. So a point that I kind of see right up here, that is 1, 4. So to check it, what I want to know is if it satisfies this guy right here. And so if I plug a 1 in, negative f of 1 minus 1 plus 4, that's negative f of 0 plus 4. That's referring back to our original function. F of 0 was that dotted guy, and it was right at 0, 0. So that means f of 0 makes 0. Negative that plus 4, that's equal to 4. So I know when I just now subbed in a 1, I got out a 4. So this point does satisfy that equation. All right, for this function, we got 2 stretches going on and a reflection, of course. All of these have reflections on them. This is reflecting still over the x-axis because it's outside of the function. We have a vertical stretch because it's multiplying all y's by 3. I'll even write that down there, y's times 3. I should write times. And we have this 2 inside that's doubling up every input we put in. That means all of our x's can be half their size. So it's a horizontal shrink by half. Or we could say half each x. All right, so we're going to do this in 2 steps here to make sure we understand what's going on. So the first thing, if we're just going to reflect that over, all of these signs will negate. So this right here is just the little flip over. So this is just negative f of x. Now if we stretch it vertically, all of our y values will times by 3. So if we're at this point right here, it has a y value of 1, it's going to be now up at 3. It's triple its size. And then negative 1 right here will become negative 3. Now these other guys are all at 0, so those just stay 0. So stretching it out vertically will get us that picture. So that's negative 3 f of x. And so then lastly, if we're going to take half of all of our x values, and they're going to be at the same heights. What that means is if we're like at 2, negative 3, if we take half of that, which puts us at 1, we'll be at negative 3. So that would be right here. For the point, let's see, 4, 0, if I take half of 4, that's at 2. Now I'm going to be at 2, 0. For this guy up here, negative 2, 3, again, at half the x value at negative 1, we'll be at 3, which will put us right here. And we also have, let's see, negative 4, 0, this one I forgot. That would be at negative 2. So sorry, these points that I just mentioned here, you can see it getting squished in a bit. So it's the same like height that we made with that blue guy. And we all go through 0, 0. But we've been squished in. So that's the graph, negative 3f of 2x. Now again, I'm like, wait, what? So let's check that we're okay. So let's check that last point. It would be negative 1, 3. That's the one right here. So what I want to know is if I plug it into this function, if it checks. So negative 3 f of 2 times that negative 1. Well, let's see what happens here. 2 times negative 1 is negative 2. So we want to know what f of negative 2 is. So that's going back to our original blue function that was dotted. F of negative 2 is right here at negative 1. So when I plug in a negative 2, I know I get a negative 1. And so then I'm saying, okay, well, let's take negative 3 times that negative 1, because I'm just following that, which equals positive 3. So look what happened. I inputted negative 1, I outputted 3. And you could check it with some more points on that, this green function here. Just check them, and they should all work by doing what I did right here. Okay, so they're not open circles. I'm gonna plug those back in just to make sure we're good. And I can re-highlight that. So this is the final answer. All right. Okay, so looking at this next one, we got a lot of movement going on here. Notice that there's 2 movements inside. Now over here on number 4, we ended up noticing this factoring let us see our movement. In this case, we had gone right 6. So let's try and do that here too. And so what I mean is we're going to rewrite this as negative 1x plus 3. I just think that makes it a little easier so we could see what's happening. So this is actually a reflection over the y-axis. That's because it's inside the function. And so we could see this is moving left 3 and down 2. So let's do that in a couple baby steps here. So first thing, if I do the reflection first, because it's kind of outside of this function, but pretty close to x. So that means all my points are going to reflect over the x-axis. So I see negative 5. That one's going to go over and be at positive 5 now. 3 is going to be at negative 3, and negative 1 will be at positive 1. So we have this picture going on, which should look like a reflection. Okay, and so then we also want to move it to the left 3 spaces and down 2. So let's do that at one step here. So left 3, let's take this big top point. Left 3, 1, 2, 3, and then down 2 spaces. This guy, left 1, 2, 3, and down 2 spaces. Left 1, 2, 3, and down 2 spaces. That puts me here. So connecting those red dots, that looks like our picture. And again, I just want to check. So I'm going to pick a random guy. I'm going to pick this guy, which has coordinates 2, negative 2. And so this is supposed to be on my new function that was created. So I want to plug it in and make sure it works. So when I plug in for x, this is going to be f of negative 2 minus 3 minus 2. So that's f of negative 5 minus 2. Well, f of negative 5, again, this is just our regular function, f of negative 5, f, that was our first dotted guy. Let's see what happens. At f of negative 5, on that original dotted blue guy, we were right here at negative 5, 0. So at f of negative 5, we're at 0. Minus 2, it makes negative 2. So that checked. Again, you could check another one, make sure that it works, but that's our function. So the red one, again, is f of negative x minus 3 minus 2.